Okay, so now we're going to look at an example of finding the extrema on a closed interval. First of all, a note about this. Here we're looking for relative and absolute minimums and maximums, okay? So, and here they're going to give us a closed interval. So let's just take a look at a graphical example. So the closed interval is between A and B. So in other words, the graph is only going to be looking at between A and B. So let's just draw a quick little sketch of something that might be it. So let's say we have A over here, and we have B over here, and let's just make up some function here. So let's say A starts off over here and kind of moves around a little bit and does something like this. Maybe it switches again and stops right here. And notice that at the endpoints we'll have circles indicate that it's closed in there. Okay, so just looking at this picture, you can see that the absolute minimum that this graph ever occurs is going to be at point A. Never gets lower than this. And at B, this thing clearly isn't a low point or a high point. And then let's identify a couple other points here. Let's call this one x sub 1, and this is another interesting one, x sub 2, and here x sub 3. So anyway, you can see that when we get to x of 1, we have a horizontal tangent here where the derivative is equal to 0, the slope is equal to 0, and again here at x of 2 and then at x of 3. So these are all candidates that we have to go and explore. And you can see, because we have the luxury of having the graph, x of 1 is you might be thinking it's a relative max, but look around, it never gets any higher than here, so this turns out to be an absolute max. This is x of 2 is just a relative minimum, and then x of 3 is a relative max. So what are the steps? Well, if you don't have a picture of the graph, the first thing you have to do is take the derivative of your function and find the critical points. Find the critical points. And number 2, do a sign analysis, a sign chart. And number 3, you always have to examine the endpoints, because they now become candidates to determine whether you have absolute max or absolute minimum. Alright, so let's go down here to the bottom of the screen and let's take a look at an example. Notice we don't have the luxury of having the graph here. So we're going to find the extrema of this function, 3x to the 4th minus 4x cubed, on the closed interval of -1 to 2. So remember, that's what the squared off brackets mean, a closed interval. So whatever critical values we find, we also are going to consider the function value of -1 and 2. So first of all, let's take the derivative, fairly simple one here. We have what? 12x cubed minus 12x squared. Well, probably we're thinking we should factor the 12x squared out, and you get what? X minus 1. So that's the first derivative. Set it equal to 0, and what are going to be our critical values, our critical points? Our critical points, what causes this part to go to 0? When x equals 0. And the only other thing we have to consider is what causes this equal to 0? Well, that's pretty simple, when x equals 1. So first thing we need to look at is, are these two critical values, are they inside of the interval between -1 and 2? And clearly they are. So let's go ahead and do a sign chart on this one. And we can see a few things here. So we have 0 and 1. So we have to look at 1, 2, 3 regions of the derivative. So make sure you label that so you don't get confused. And let's just pick an easy one like -1. So you go back over here. Any value squared is going to end up being positive, right? Times 12 is going to be even more positive. So you don't really have to look at this portion so much. But we do need to look here. If we put in a -1 for x, -1 minus 1 becomes negative. So we have all values are negative, indicating that the function is decreasing. We know that at 0 it's equal to 0. And then to the right, somewhere between 0 and 1, I guess a half would be a nice choice. So if we pick a half, 1/2 minus 1 is negative, right? So if it's negative right here, it doesn't change signs, does it, at 0, like we thought it might. So this is not a relative minimum. So it's not going to be a candidate for us. And at 1, what happens? Well, we know it's equal to 0. Let's look to the right. Pick, say, the number 2. Once again, 2x squared is going to be positive, so we don't really need to consider that. We just need to look at this part. 2 minus 1. 2 minus 1 gives us a positive. So here we do what? We start increasing. So this might be a relative minimum, or it might be the absolute minimum on this closed interval. So let's just go ahead and plug in the values here. We're going to look at the function value of -1. All right. So we have 3 -1 to the 4th power minus 4 -1 to the 3rd value. And what does that equal to? Well, that becomes +1. So we have a +12. This stays negative, so we have -1 times a -4 is a +4. So this thing reaches a value of 16. Let's see, did we do that right? Sure didn't. Let me go back and fix this. We have -1 to the 4th, which is a +1, so we actually have 3, not 12. And then this is a -1 plus what? Plus 4. That equals 7. Sorry about that mistake. Gotta be careful with these. Then let's go look at when the function value equals 0. That was one of our critical points. So we're pretty sure this is not it, but let's try it anyway. So we have 3 times 0 to the 4th minus 4, 0 to the 3rd. And of course you get 0 minus 0 is 0. And then let's look at the next one on the line. So we have the function value of 1. Not the derivative, but the function value. So plugging in a 1 here, you get 3. Plugging in a 1 here, you get what? 3 minus 4, and that equals a -1. And then finally, let's look at the endpoint, f of 2. So notice that we are also looking at the function value of the endpoint. So putting a 2 right here, we get 2 times 2, 4, 8, 16. Is that right? 16 times 3 is 48. And plugging in a 2 here, we get 8. 8 times 4 is 32. 48 minus 32 is 16. So here, this tells me that I have a what? This is my absolute max, and I reach an absolute minimum right here where x equals 1. So this is a process you can use to come up with minimums and maximums, absolute minimums and maximums on a closed interval. Alright, I hope this video helps. Go out and try a few problems.